Good morning. Good morning. I am Dr. Balamurugan, Professor Chemistry, NPR College of Engineering and Technology. Today we are going to see heat treatment of steel alloys. Heat treatment of steel. So what is heat treatment? The heat treatment of steel is defined as the process of heating and cooling, both heating and cooling of solid steel articles under carefully controlled conditions. Under carefully controlled conditions is called as heat treatment of steel. So during this process, heat treatment of steel, some of the important properties, some of the physical properties are altered without changing chemical composition. Without changing chemical composition. Okay. So what is the why we are treating steel for heat treatment? So why steel is treated for ups and downs of various temperatures? What are the objectives? This heat treatment causes improvement in magnetic and electrical properties. There is a improvement in magnetic and electrical properties. Refinement of grain structure, to refine the solid steel's grain structure, and removal of imprisoned trapped gases. Removal of imprisoned trapped gases and removal of internal stresses. Removal of internal stresses of steel. Last one, this heat treatment improves fatigue and corrosion resistance. Fatigue and corrosion resistance. So next, there are 6 types of heat treatment of steels available. The process are annealing, hardening, tempering, normalizing, carburizing, and 6th one, nitriding. So these are the various processes present in heat treatment. Various processes present in heat treatment. So let me see one by one. And first process is annealing. What is annealing? Annealing means softening by heating. So this softening is carried by heating the steel into high temperature and followed by slow cooling in a furnace. Heating to a high temperature followed by a slow cooling in a furnace. The purpose of annealing is to increase machinability, and it also removes imprisoned gases. It also removes imprisoned gases. Okay. So there are 2 types of annealing process are available. 2 types of annealing process are available. So 2 types of annealing process are available: low temperature annealing, high temperature annealing. Low temperature annealing is called as process annealing. High temperature annealing is called as full annealing. Low temperature annealing or process annealing. So it is the process in which the steel is heated below lower critical temperature of the steel and followed by slow cooling. So note this point, below lower critical temperature followed by slow cooling. Purpose of this low temperature annealing is it improves machinability by relieving the internal stresses and strains, and it increases ductility and shock resistance, and also third one, it reduces hardness. And second type of annealing is high temperature annealing, full annealing. It involves heating the steel to a temperature 30 to 50 degree above higher critical temperature. Is called high temperature annealing. Okay, and allowed to change in internal changes takes place, then cooled to room temperature. This is high temperature annealing. So temperature range for high temperature annealing is mild steel 840 to 870 degrees centigrade, and medium carbon steel 780 to 840 degree centigrade, high carbon steel 760 to 780 degree centigrade. And the purpose is to increase the ductility and machinability, and it makes the steel softer together with an appreciable increase in its toughness. Second process is hardening or quenching. So in this process, the steel is heated beyond the critical temperature, and the cooling process is carried out suddenly. So which is carried out by dipping the hot steel into brine water or other some fluid. So this hardening increase the hardness of steel. The faster the rate of cooling, harder will be the steel produced. If the rate of cooling is very fast, if we are dip the heated steel into brine solution or other some liquid immediately, then the hardness will be more. Medium and high carbon steels can be hardened, but low carbon steels cannot be hardened. Purpose is it increases its resistance to wear and ability to cut other metals and strength. Wear resistance, ability to cut other metals, but steel become extra brittle, and it increases abrasion resistance so that it can be used for making cutting tools. Abrasion resistance so that it is used for making cutting tools. And third process, tempering. So it is the process of heating the already hardened steel to a temperature lower than its own hardening temperature, and then cooling it slowly. In tempering, The temperature to which hardened steel is reheated. Reheated is great significance and controls the development of final products. For retaining the strength of the harness and reheating temperature should not exceed 400 degrees centigrade. So reheating temperature should not exceed 400 degrees centigrade. For developing better ductility and toughness of the steel, reheating temperature should be in a range of 400 to 600 degrees centigrade. 400 to 600 degrees centigrade. Okay. Purpose. What is the purpose? The purpose of tempering is, in tempering process, it removes stress and strains and might have developed during pinching. It removes completely stress and strain. And also another important point, it reduces the brittleness and hardness, but toughness and ductility is increased. Brittleness and hardness reduced, at the same time the toughness and ductility is increased. Cutting tools like blades, cutters, tool bites always require tempering. So cutting tools are generally carried out tempering process. And fourth process one, normalizing. Normalizing process is nothing but heating the steel to a definite temperature, but above the higher critical temperature, and the cooling process is carried out gradually, slowly in air. In air. So the purpose of is normalizing purpose, or during normalizing it recovers homogeneity. So the structure is homogeneous throughout the solid. It refines grain. It removes, normalizing removes internal stresses, and normalizing increases toughness. Normalized steels is suitable for the use of in engineering works. Suitable for engineering works. And compared to annealing process, it took very less timing. Very less timing. And fifth process, carburizing. The mild steel article which is heated with carbon then it is called the process carburizing. So the heating temperature, carbon, charcoal pieces, small pieces, heated with the charcoal pieces, the heating temperature is 900 to 950 degrees centigrade. 900 to 950 temperature. At this temperature, the charcoal, at this temperature, charcoal's carbon are absorbed to a required depth. Mild steel absorb carbon particles to a depth, and after absorbing carbon, the article is then allowed to cool slowly in the iron box itself. The outer skin of the article is converted into high carbon steel containing about 0.8 to 1.2%, 0.8 to 1.2 percentage of carbon. And purpose to produce hard wiring surface on steel article to produce hard bearing surface on steel articles. Process is nitriding. So heating the steel article in presence of nitrogen. So nitrogen is added to steel. So nitriding is a process of heating a metal alloy in presence of ammonia. Heating the alloy in presence of ammonia at a temperature about 550 degrees centigrade. The nitrogen is obtained by the dissociation of ammonia. The ammonia is dissociated into nitrogen and hydrogen. This dissociated nitrogen combines with the surface of the alloy and make it hard. There is a formation of hard nitride on the surface so that it is hard. So purpose of nitriding is to get a super hard surface. To get a super hard surface. So today's class, so we have seen heat treatment of steel. So heat treatment of steel. The heat treatment process is nothing but so by altering or by exposing the steel article into higher and lower temperature followed by specific cooling. So we have seen six process annealing, low temperature annealing, high temperature annealing, and second one is tempering, hardening, normalizing, carburizing, and the last one is nitriding. Okay, that's all about the today's class. Thank you.